Hello, ladies and gentlemen. I'm here to introduce to you GCSE in computer science. There are 8 basic areas that will be covered during GCSE, all of which are indicated on this screen. I'll go through each of them in a little bit of detail, and I apologise if I wander off and which on about some of the stuff. It is something that I have a strong interest in. The basics of computing come down to algorithms. You will be, I'm sure, aware of recipes. That is a basic algorithm. You have a set of ingredients and a set of instructions, and if you follow the instructions, you will get to something that is hopefully very edible. A computer program is just another algorithm. It's a set of information and a set of instructions that, if you use the information and follow the instructions, should produce something at the end of it. And this is the basic science behind computer science. The theory of computing began a few hundred years ago now, probably starting with Mr. Babbage, long before computers existed, and for many years, and many decades even, some great minds had to think through how a computer would work, because they didn't have the technology to actually make it work in reality. This started to change around the time of Alan Turing, when he created his machine to break the Enigma code, and he was one of the very early pioneers of computing. The second aspect of the course will be programming. This will run through probably the whole of the course, running in parallel to all the theory stuff, and we will be using Python 3. It's a very nice language to get started with. It's powerful, easy to understand, easy to write, easy to read. And during this time, you'll be learning the basics of programming, from inputting data, outputting data, through to making branching, which is your if and else statements, and building up to iteration, which is your for loops and your while loops, and finishing off with subprogramming, which are designed to make programming a little bit simpler, easier to debug, and easier to understand. If your students, if you do really well at this, I will give some students the opportunity to try and build graphical user interfaces, but that'll be something that's outside the scope of this course. The next aspect is how data is represented. We have to deal with numbers, and we have to deal with characters, images, and sound, basically, on computing. So we have to look at the number bases of binary and hexadecimal, because computers only understand binary. So you'll have to learn how to convert between binary and ordinary decimal numbers and hexadecimal, and then we'll have to do a bit on binary arithmetic, which involves adding, subtracting, and a little bit of multiplying and dividing. Characters represented by ASCII and Unicode. We will spend most of the time using ASCII, but Unicode will become part of it, and it's just a way of representing characters on a computer and transmitting character information via computers. We'll be looking at images, which will limit to bitmaps, and how the resolution of those changes the quality of the image. And finally, in this section, we'll be looking at how computers can represent sound in binary. Next, we'll be looking at computer systems and what makes a computer system. So we're looking at the hardware and the software. We'll be looking at a bit on Boolean logic and how and or not gates are used to manipulate data and make things happen. We'll be classifying software, which is basically operating system software and application software. We'll be classifying programming languages from high-level and low-level languages, and interpreted and compiled languages. And we'll be looking a bit at the systems architecture, which is how basically the CPU, the central processing unit, gets data, processes the data, and sends it out again. It's the fetch execute cycle, as it's called. We'll be looking at networks. We'll be looking at different types of networks, essentially wired and wireless, and we'll be looking at how computers are connected together. The network topology is really a study of how computers are connected together, and we'll look at the star and bus topologies and the advantages and disadvantages of those. Network protocols we'll be spending some time on. There's quite a few protocols. A protocol is just a set of rules that allow computers to communicate with each other. So it's not straightforward for one computer to talk to another computer. You have to agree a set of rules or protocols before that can happen. We'll be looking a bit at network security and ways of controlling who has access to data and who can change data and how that happens. And we'll be looking at the TCP IP 4-layer model, which is basically a set of protocols that dictate how most computers connected on network will send data from the computer. So the stuff that I want to produce, like this video, will then go through the 4-layer model to your computer where it'll be displayed, and then the information coming back will have to go through the same process. We'll be spending some time looking at cybersecurity. Cyber threats are a big thing nowadays, and increasingly a bigger problem for computer networks. We'll be looking at some of the social engineering aspects, which is things like phishing and how malicious agents, as they're called in the course, try and get information from you in order to get into your account, to get your bank details, get your email address, get your passwords, that type of thing. That's social engineering. We'll be looking at malware, which is basically any program that does something that you would not expect it to do. So stands for malicious software. And we'll be looking at some of the ways that we can protect computers and networks from these cybersecurity threats. Relational databases and SQL are becoming a bigger and bigger aspect of computing with the rise of the internet and these big companies, the likes of TikTok and Facebook and what have you, that collect information about you and your interests and want to be able to use that to improve the quality of their service so that you can see what they think you want to see. And that's all done with databases. And so we'll spend a little bit of time understanding what a relational database is, and then using SQL, which stands for Structured Query Language, to access and change that data and manipulate that data. The final aspect of the course is the ethical, legal, and environmental impacts. They're becoming bigger and bigger now that everybody is connected. So ethical interests are things like, just because you can do something, does that mean you should do it? For example, Google Maps, they sent cars around filming the routes that they were taking, and which means that people have been filmed in their back gardens, in their bedrooms and things like that. Should they be allowed to do that? What sort of things do Google have to do to not upset the general population? That's an ethical aspect of computing. There are legal aspects. There's the GDPR Act, which limits what information can be shared about a person. And then there's environmental impacts. For example, I don't know if you knew this, but Bitcoin, which is produced via an algorithm, it is estimated that the electricity that Bitcoin is using to generate new Bitcoins at the moment is roughly the equivalent to a whole island's worth of, small island's worth of electricity consumption every single day. So these are some of the things you need to be looking at. The course is going to be assessed by 2 papers. It's all written exams. There are no coursework. So paper 1 is all about the computational thinking and programming skills, which is the first 2 aspects I talked about, the algorithms and then the programming and debugging programs. So that's the first paper. The second paper is all the rest of the course, which is more about how computers do things and how networks are connected and that sort of thing. So the first, just to repeat, the first paper is all about programming, really, and the second paper is all about the computers and the networks. So what makes a good computer science student? Essentially an interest in computing. If you have a strong interest in computing, that's the biggest hurdle to get over. If you like problem solving, it will help a lot. The programming side of the course, which is a significant amount of it, is all about using computers to solve a problem by creating a program. And it is not an easy easy to do, because by definition problems are difficult. So you have to be willing to think hard, try things out, be resilient, and accept that you're going to be wrong quite a lot of the time, and keep trying and trying again until you get the problem solved. So it is a difficult task, that bit of it. And then if you are thinking of studying computing or programming after GCSE, then I would certainly recommend it. As it's not an essential thing to do, but it's certainly, I would recommend that you look at the computer science GCSE, as it will give you a good grounding in computing. And I need to highlight some of the reasons not to do computer science. So if you like playing computer games, or you're not interested in how a computer works, then this isn't the course for you. It is more about wanting to get into the detail about computers, how computers are put together, how they work, how networks work, and the details of how programs are created and things like that. It's definitely not an easy option. It's something that will stretch your brain, and it involves a reasonable amount of memorizing information. So you need to be willing to put a lot of effort into this. If you do, then you'll get some very good grades out of it. But I would encourage anybody who has a good interest in computing and likes this type of thing to get involved with this course. If you do have any further questions, just get your student to send me a message on Teams, and I will try my best to answer it. Thank you very, very much.